Is the following series convergent or divergent? Remind yourself of the theorem that we proposed. If series an, n starts from 1, goes to infinity, is a convergent series, then the limit of the general term as n goes to infinity must be equal to 0. Out of that theorem, we defined a test for convergence. Our test says if the limit of general term as n goes to infinity is not 0, so for sure you can say that the series of n start from 1 goes to infinity is a divergent series. So we're going to use the test and check to see if we have a convergent sequence or not, a convergent series or not. So here your an is equal to ln of n squared plus 1 divided by 2n squared plus 1. If I take the limit of an as n goes to infinity, it is the limit of ln of n squared plus 1 divided by 2n squared plus 1 as n goes to infinity. We can move limit inside the parentheses. You get the ln of the limit, let me change the color, of n squared plus 1 divided by 2n squared plus 1 and close up the parentheses as n goes to infinity. If you plug in infinity, direct substitution gives you ln of infinity over infinity. So here you can apply L'Hopital's rule. So for the quantity inside, you get infinity over infinity. So apply L'Hopital's rule. You get ln of, now the limit of the derivative of the numerator, which is 2n, divided by 2 times 2, which is 4n. And then take the limit as n goes to infinity. But you can simplify this. You get the ln of, where if you cancel out n and n, you end up with 2/4, which is 1 over 2. You have ln of a half. Well, it's not equal to 0. The limit of the general term is not 0, so the series is divergent based on the test that we introduced. So this is what you're going to write. Since the limit of ln of n squared plus 1 divided by 2n squared plus 1 as n goes to infinity is equal to ln of a half, and it's not equal to 0, so based on our test, the series is divergent. The series is divergent. Common mistake for students on the exam. Frequently, we see that students make the following common mistakes. Students write, since the limit of ln of n squared plus 1 divided by 2n squared plus 1 as n goes to infinity is equal to ln of a half, and it is a unique numerical value, so the series summation of ln of n squared plus 1 divided by 2n squared plus 1, n starts from 1, goes to infinity, is a convergent series. That's the first common mistake that we see on the exam. The second common mistake that we see on the exam is the answer to a question wrong. The question is the sequence an equals to ln of n squared plus 1 divided by 2n squared plus 1 convergent sequence? And students write since the limit of an as n goes to infinity, which is the limit of n squared plus 1 divided by 2n squared plus 1 as n goes to infinity, is equal to, let me add ln as well, is equal to ln of a half, and ln of a half is not 0, so the sequence is divergent. This is another common mistake that we frequently see on exams. Please make sure to avoid these types of mistakes.